So we're going to talk about quadratic transformations. Go ahead and take a moment, set up your notes, upper right-hand corner, quadratic equations, Unit 6A, Homework 2 with the appropriate date, and make sure you have the right side of your paper set up for any questions or comments you might have as we go through the notes. So here we have vertex form of a quadratic equation. And I want to take a moment and point out some key characteristics of the vertex form. So one thing to notice is that when the value of A is negative, that A negative is going to be a vertical reflection over the x-axis. A can also stretch or compress a parabola. So if A is greater than 1, for example 2, 5, 25, you're going to look at a stretch. It's basically going to stretch it up and down and make the parabola get narrower. When we talk about a compression, this is where the value of A is less than 1 but still greater than 0. So we're talking about 1/2, 0.33. Those numbers will press coming down and going up and make the parabola get wider. So stretch is going to make a narrower parabola. A compression is going to make a wider parabola. Now H is going to be a horizontal translation, and that means either left or right. And this one can be kind of tricky because the original equation is x minus h. So we're looking at just the value of h, x minus whatever h is. So if h is a negative value, we're going to notice that a double negative is going to make this addition, and we'll talk about this more in class. But we're talking about moving left, or moving the parabola left, or moving the parabola right. And then finally, the value of k, and this is where you're going to have a vertical translation, where you're either going to move the parabola up or down on the graph. And so all of these pieces, I can look at just the equation and be able to tell you how it's going to move without even graphing it. Go ahead and take a moment, pause copy before continuing on. Now, when I'm looking at standard form of a quadratic equation, it's not quite as easy to be able to tell what it's going to do, but there's still some pieces that will give me some clues. So as with vertex form, when it's in standard form, that negative in front of your A value is going to represent that vertical reflection over the x-axis. And as what we learned from last class is that when we have a parabola that opens up versus a parabola that opens down. And then once again, A, as with the vertex form, the standard form, we're going to talk about that vertical stretch where the parabola is going to get narrower if our A value is greater than 1, or a vertical compression. And this is where A is less than 1 or greater than 0. So for example, 0.25, 1/4. Those things are going to give me a compression or make my parabola wider. And then C, our constant term, that actually represents the y-intercept of the parabola. So I know where my parabola is crossing the y-axis. And C gives me that piece of information. So let's try an example. Here I have an equation. It's quadratic because of the square. And this is in vertex form. So looking at it, you should be able to tell me what happened to my graph. How did it transform from my parent function? So let's look at what the negative does right here. Remember that that's going to represent the vertical reflection over the x-axis. Instead of the parabola opening up, it's going to be opening down. Now the 1/2 is going to tell me whether it's a stretch or compression. And because it's less than 1 but greater than 0, that's going to be a vertical compression. My parabola will be wider. And then my h, it's going to be a horizontal translation left. Remember, it's x minus h. So when I have a negative h value, that double negative will be a left 2. And then my k value tells me that it's a vertical translation down 4 since it's minus 4. Now let's look at a quadratic in standard form and use the pieces we've just learned to help tell me something about the graph of it. So we look at 3. We notice it's positive, so it's already going to stay opening up, but 3 is greater than 1, so that's going to represent a vertical stretch, or my parabola is going to get narrower. And then because my C value is a positive 7, my y-intercept is 0, 7. It's crossing the y-axis at 7. So go ahead, take a moment, pause, copy, and we're going to practice vertex form and standard form, being able to tell me key characteristics of each without graphing them. So let's talk about quadratics without a graph, and we're going to look at specifically standard form. So here I have an equation, y equals x squared minus 2x minus 3. And I want to be able to tell some things about this without graphing it on a calculator. First thing you should be able to tell me, is this a maximum or a minimum? And once again, we look at our a value to be able to tell that. If a is a negative, it's going to open down, which will give me a maximum point on the parabola. If the a value is positive, it's going to open up, which gives me that minimum point on the parabola. And since our a value is positive here, we know that this is going to open up and that it's a minimum. Now, what about vertex? How do I find the vertex without graphing it? And one of the pieces we can use is we can find the x-coordinate of the vertex by using this equation right here. X equals negative b divided by 2a. And remember, b and a refer to the parts of your standard form quadratic equation. So b is going to be negative 2, a is going to be a positive 1 here. So I'm going to go ahead and just plug in b and a based on the standard form of the quadratic equation I have. And then it's just a matter of simplifying. And here, this tells me that my x value of my vertex is 1. All I have to do now to find my y value is plug my 1 into the x values of my quadratic and solve. And once again, simplify, use your calculator. Make sure you're using parentheses when you plug in values. And so I get y equals negative 4. So my vertex of this parabola is 1, negative 4, based on getting the x value and the y value. So let's try another example. Looking at this, do I have a maximum or minimum? And once again, that's going to come from knowing whether it opens up or down. And because my a value is negative, I know it opens down, and this provides me with a maximum point, or the highest point on the graph on the parabola. So I want to go ahead and use x equals negative b divided by 2a to find my vertex. This will give me my x value. I'm going to take my b value of negative 8 and my a value of negative 2 and plug them into the equation. Once I plug in, go ahead and simplify. And that's going to give you x equals negative 4. Now once I have the x value of my vertex, I can go ahead and take that negative 4 and plug it into my equation. Once again, please make sure you use parentheses when you plug it in. And then from there, it's just a matter of simplifying the equation. And that gives me y equals 5. So the vertex of this parabola would be negative 4, 5. So once again, being able to do a quadratic without graphing it, being able to tell key pieces is an important part of understanding a quadratic equation in standard form. Take a moment, pause, copy before continuing on. So let's talk about graphing quadratics now without using a calculator. So I have a quadratic equation, y equals negative x squared minus 4x plus 4. Step 1, we want to find the vertex of the graph. That's going to be the key part of graphing any quadratic. So I use x equals negative b divided by 2a. I plug in my b value of negative 4, and I plug in my a value of negative 1. Simplify, I get x equals negative 2. Plug that negative 2 back into the original equation for your y value. So my x value being negative 2, my y value being 8, that's going to be the vertex of my graph. Step 2 is you want to create a table of values. Now the key here is you want to pick symmetrical values. It's going to be way easier to graph. And this is one of the reasons why we find the vertex first. That vertex is going to be the middle of our table. And so I start with negative 2, 8, and then I go up equally And then I have -3, -4, -5, and then -1, 0, 1. Now, in order to find the other pieces, I'm going to plug these values into my x and create a table. So I plug -5 in, and I get a y value of -1. I plug -4 in, and I get a y value of 4. I plug -3 in, and I get a y value of 7. I plug -1 in, and I get a y value of 7. I plug my 0 in and get a y value of 4. And then finally I plug 1 in, and I get a y value of -1. Now, just looking at the table, I can tell that this is a quadratic. It has that U shape, where on either side of that 8, you notice my numbers match each other. And that's kind of that characteristic I look for. When I look at a table, I can tell if it's quadratic by seeing that piece where it's matching on either side. And then finally, you need to plot your points. Once I plot all my points, once again, I see that characteristic U shape. And remember, you're going to have that curve. It doesn't come to a V point. It has a curve on it at the vertex. Go ahead and take a moment, pause, copy, before continuing on. So an important piece to come to class with is calculator steps for finding solutions for a quadratic equation, whether it's in vertex form or if it's in standard form. Take a moment, pause, and copy down the steps, and be prepared to apply them when you come to class next. So here we have a try it out section. I want you to answer questions 1 through 4 based on this quadratic, and then describe the transformation in step 5. We'll go over the answers to your questions when we come back to class. Have a great one. I'll see you next class.